everyone! Today I will be teaching you how to use a refractometer in order to measure the sucrose concentration in fruit. So let's start off by defining our refractometer. So refractometers are handheld optical tools that can measure a wide range of measurements depending on the solution that is dropped onto the prism. So these measurements can include the pH levels, the salt concentration, or in this case, the sucrose concentration. Refractometers are used in the farming, brewing, and cooking industry in order to test the quality of a fruit. Now, they are portable and they provide fast and accurate calculations. Now, why is it important to test the sucrose concentration in a fruit sample anyway? Well, within a solution of fruit, there are two major components, water and sucrose. The more sucrose a fruit sample contains, the more nutritious it is said to be, and it has a better quality. Now, on the other hand, the less sucrose a sample contains, the less nutritious it is, and the less overall quality it contains. So, how exactly is sucrose measured by a refractometer? Well, the refractometer measures sucrose through a unit called the Brix value. So after you drop a solution onto the refractometer prism and look into its optic lens, what you will see is a scale that looks like this. And this scale will tell you the solution's Brix value, or in other words, it will tell you the concentration of sucrose within the sample. So once you test a sample and get the Brix value, this Brix value represents that fruit as a whole. And now, because each fruit has a different chemical makeup, every fruit requires a certain Brix value that's considered normal for that specific type of fruit. Now, there are many Brix value charts, such as this one, that can easily be found online. And what they do is they map each fruit according to their appropriate range of Brix values. Now that we have learned what a refractometer is and why we measure sucrose, we will now learn how to use the refractometer in order to test sucrose levels. So in order for the refractometer to give a Brix value reading on its scale, which again looks like this, we must hold the refractometer in the direction of a light source. Now, you may be asking why this has to be done. Well, in science, light refracts or bends when it enters a different medium. So when a solution is dropped onto the refractometer and is held towards the light, what the refractometer is actually measuring is how much the light bends as it enters through that specific solution. And the more the light bends, the higher the Brix value will be. So what exactly in a fruit solution causes light to bend? Well, the answer, of course, is sucrose. So the more concentration of sucrose in a solution, the more the light will bend through it, and which in turn will give this solution a higher Brix value. So notice how the refractometer functions in such an organized manner. So with that said, refractometers must also be calibrated to 0 before testing a solution, just so we can make sure that the scale is properly balanced. So one way to do this is by adding a few drops of distilled water onto the refractometer, which will give it a Brix value of 0. And why does distilled water have a Brix value of 0? Well, the answer is because it is stripped away from any added nutrients or components that any other type of water might have. Distilled water has nothing inside of it that would likely cause light to bend into it as it is being entered through the solution. So let's go ahead and do that right now. Let's add a few drops of distilled water onto the prism. And let me close the lid and look through the refractometer over the light. And, okay, perfect. Now, as expected, the refractometer gives the distilled water a Brix value of 0, which means that it is calibrated and ready to test sucrose concentrations of fruit. So let's start off by testing the sucrose concentration of this apple right over here. Now what I'm going to do is to slice a part of this apple and squeeze its juice onto the refractometer. So let's go ahead and do that right now. Right, now I'm going to close the lid and hold the refractometer up into the direction of the light. And okay, as the refractometer gives the Brix value, I can see that this apple has a Brix value of 15. Okay, so what exactly does that measurement mean? Does this Brix value represent an apple of poor, average, good, or excellent quality? Well, let's see by looking at our Brix value chart. So, according to the appropriate Brix value range for apples, a Brix value of 15 falls under the good category, which means that this apple is of good quality. So again, it's important to compare the Brix values we get from the refractometer to the fruit's optimal Brix value chart, because this helps us understand whether or not the fruit is truly of quality. So now you all know how to calculate sucrose levels in a fruit with the use of the refractometer. Thank you all for watching.
Thank you.
Thank you.